right, we have a cosine double angle problem for number 4. So again, the first thing I'm going to do is do that little bit of expansion. Cosine of 2 theta is the same as cosine squared minus sine squared. Rest of the problem stays the same. All right, now I'm going to combine my like terms before I move on. So my like terms are my sine squareds, same variable, same exponent, those are like terms. So the cosine squared is just going to hang out. I have a negative 1 sine squared plus 6 sine squareds. So that's 5 sine squareds. And now, at this point, I need to decide whether I want to work with sine or cosine. You can go either way. There's not a right answer here. Since cosine is out here, cosine squared is out here on its own. It doesn't have anything in front of it. I won't have to do any distributing. I'm going to change cosine squared into 1 minus sine squared using our favorite Pythagorean identity. And then the rest of that equation right now is going to stay the same. And then again, I'm going to combine my like terms. It's a little bit repetitive here. Substitute, combine, substitute, combine. Here I've been negative sine squared and positive 5 sine squared. So that's going to be 4 sine squared. And now I'm going to solve. Now we just solve. I'm going to subtract 1 from both sides. Divide by 4. I have sine squared. I want a single sign, so I've got to take the square root. When you take the square root of both sides, a couple things to remember. First, you have to do it to both sides. We need the plus minus. That's a big deal. And when we take the square root of a fraction, we're taking the square root of the top and the bottom. Sometimes the bottom gets lost there. So this is plus and minus square root of 3 over square root of 4. Square root of 4 is 2. So that is sine. I really like that one. That attention to detail there is really important. Now we're looking for values in all 4 quadrants for this one for theta. And since sine is radical 3 over 2, we're going to do all of our thirds. So in the first quadrant, pi over 3. In the second quadrant, 2 pi over 3. In the third quadrant, 4 pi over 3. And then the fourth quadrant, 5 pi over 3. I really dig that one. That doesn't surprise any of you. All right, that is number 4.